Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. Friends, today we are going to start one of the very important topic for your subject electrical machines, that is the characteristics of synchronous machines. But before we start this, we are going to take some of the remaining topics of the yesterday's class, that is the construction, basic construction and operating principle that we were discussing yesterday. So some of the topic we are going to discuss today, and then we are going to discuss the characteristics of the synchronous machine. Now all of you who are joining me, please tell me whether my audio and visual quality is okay for you so that we can proceed for the session. Hello Shankar Natarajan, how are you? Please tell me beta whether my audio and visual quality is okay for you so that we can proceed for the session. All the candidates who are joining me, please quickly tell me whether my audio and visual quality is okay. Okay, so Shankar Natarajan is reporting that my audio and visual quality is okay. Now we can proceed. Now some of you may be joining me for the first time for this startup series, so let me just elaborate what is the agenda, what we are doing in this session, in this series of sessions. See, just 15-16 lectures back we have started the startup series on the Gradeup platform for the GATE and engineering services aspirants, and now we are starting with electrical machines, that is one of the core subject for your electrical engineering. It's okay, Ramkrishna? Okay. So we have discussed some of the starting sessions. You can see on the Gradeup playlist, Gradeup GATE channel on playlist, you can see the previous sessions if you have missed them. And now we are discussing the characteristics of synchronous machine, and we will be discussing some of the constructional details regarding the armature winding of the synchronous machines. I hope you are okay with this. Before we start this session, there is some important information for all of you. Just focus here. The Gradeup is offering to you free of cost classes in this time. Everybody is locked down, everybody is restricted to stay in their home. For example, electrical engineering, Gradeup is offering the Engineering Services 2020 mains practice classes at 9 AM in the morning. M.N. Ramesh Sir, Chandan Jha Sir and Rakesh Chavleja Sir, they are taking the classes. Chandan Jha Sir is taking concept on fingertips classes at 12 PM. I am taking engineering ethics classes for engineering services 2021 paper 1 at 1 PM. Vijay Bansal Sir is taking concept on fingertips classes at 2 PM. And M.N. Ramesh Sir is taking concept on fingertips classes at 7 PM. I hope it is clear to all of you. The second most important information for you beta is on your screen about the Target GATE 2021 electrical engineering course. The most important feature of this course is that it is going to be a bilingual course, which means it is going to be delivered in both Hindi and English, so that language is no more a barrier for your learning. Shankar Natarajan beta, these 16 lectures are not only about the synchronous machine, they deal with the basic introductory part of the rotating machine, and that is available in the Gradeup GATE channel, YouTube channel. Also it is available, but it is better that if you switch to the Gradeup app, then there is going to be lot more videos, utility videos for you, which you can see and you can learn a lot of things. I hope beta it is clear. Now we are going to start with the Okay, one more information for you. If you want to test where you are standing regarding this upcoming Mega Mock Challenge schedule, then for SSC JEE Paper 1 2019-20, the live date is going to be 9th of May 2020. UPPSC Assistant Engineer Paper 1 for 2020 is going to be live on 16th of May 2020. UPPSC Assistant Engineer 2020 Paper 2 Mega Mock Challenge is going to be live on 23rd of May, and BYJU'S Steel Management Trainee 2020 is going to be live on 30th of May. So you can take the snapshot. These are the important dates for your upcoming Mega Mock Challenge test. So if you want to check where you are standing, then you can check how you are competing in this examination. Now we are going to start with the armature winding of the synchronous machine. But before I start, let me tell you that all of you, please try to like this page and share this video among your friends and colleagues, because the number of live candidates is very less and it is a kind of motivation for us. The more you are in the live classes, more number of students, it is a kind of motivation for us to keep on making such video, for you. So don't forget to like this page and share this video with your friends and colleagues. Now I am going to start with this armature winding in the synchronous machine. Now you all must be knowing that armature winding you can classify into two types, that is concentrated winding and distributed winding. Now in general, if you ask me what is the difference between concentrated winding and distributed winding, the idea is, suppose you are having a slot like this. I am just giving you a small understanding so that you understand a little bit. Later on we are going to discuss it in detail. Okay, suppose it is your concentrated winding. So what is going to happen? Concentrated winding means all the conductors are going to be placed in the same slot. So definitely this slot depth is going to be more. When the slot depth is going to be more, there is more iron needed for the core or the structure. I hope it is clear to all of you. If you are going for the distributed winding, what is happening? Instead of putting all the coils or the conductors in the one slot, what we are going to do? We are going to distribute the different coils in the different slots. How we are going to do it? Suppose you are having slots like this. You remember your armature winding is on the stator, something like this. So what you are going to do, instead of concentrating all the coils conductor in the one slot, you are going to distribute them across the periphery in different slots. Ranjit Mal is saying, sir, kal aapki class ka notification nahi mila. I think there is some problem. I don't know, some of the students are reporting like this, but from our side there is no problem. We are 100% sure in that. Okay, now let us focus here. So you can say that first classification is concentrated winding and distributed winding. Now distributed winding you can have two types. Number one is full pitched winding, and the short pitch winding. This we'll understand what is full pitch winding, what is short pitch winding. When the coil, we are saying when the coil is spun, simply you can understand when the coil is spun is equal to pole pitch. All these things we are going to understand. Ram Krishna is asking, sir, salient pole or non-salient pole? Beta, right now we are discussing non-salient pole, cylindrical rotor. Okay. Right now we are discussing cylindrical rotor only, because for if you see for salient pole, if you see, there is a little complex analogy that we are going to discuss later. Okay, now focus here. And right now when we are saying armature winding, beta, when we are saying armature winding, so armature winding is on the stator. So we are discussing about the stator. So I think there should be no confusion. Right now we are not talking about the rotor winding. But still I am telling you that right now we are discussing the cylindrical rotor only, not the salient pole. Now beta, this short pitch winding is when the coil span is less than pole pitch. Then we are calling it as a short pitch winding. This short pitch winding is also called fractional pitch winding. This is also called fractional pitch winding. Okay. Now this short pitch winding or the fractional pitch winding can be further divided into two types, that is integral slot winding. Let me just put it here so that you can see the content on the screen. That is integral slot winding and fractional slot winding. What is integral slot winding? Beta, when the slots per pole per phase is integer, then we call it integral slot winding. And when the slots per pole per phase is not integer, then we call it a fractional slot winding. That we will see in later part. If you are interested, then I will discuss this fractional slot winding also. But let us first see the starting things what we have to consider. Okay. All of you now focus here. If you see the sinusoidal flux distribution, suppose this is the sinusoidal flux distribution. This is the sinusoidal flux distribution. Suppose it is something like this. If it is a sinusoidal, then it is going to be something like this. For one cycle, suppose this is the magnetic field density and this is beta, suppose theta you can say, or the space angle you can say. Now you see, suppose you are having even harmonics. We are discussing right now, suppose with the even harmonics. So if you are having an even harmonics, then it is going to be something like this. Yes or no? Suppose this is your fundamental, so we are calling it as even, and suppose it is even harmonic or the second harmonic, so you can say. So for one cycle it is having half cycle, it is having full cycle, or for one cycle it is having two cycles. I want to show you why even harmonics are not present and only the odd harmonics are present. Now suppose you are having the coil sides like this. Suppose this is the coil sides you are having. Okay. Just have little bit of patience till I draw the diagram. This is very important so that you understand this. So what is happening? Suppose you are having the coil like this. Okay. This is one coil side, suppose A, B, and this is another coil side, suppose it is C, D. So what is happening when you see for this conductor or the coil side, both the fundamental and the second harmonic, this is even harmonic and this is fundamental. So they are in the same phase, you can say. Yes or no? They are in the same phase. So the EMF induced is going to be in the same direction. Yes or no? But if you come to this coil side CD, what is going to happen? The E1 is going to be in this direction, so that E1 is going to be added with this AB section and CD section, but this second harmonic component is having the opposite phase, because this is the fundamental and this is the second harmonic, so it is going to be in this direction. So if you see the even harmonics beta, the even harmonics are going to cancel out each other. Even harmonics cancel out each other, whereas if you see the fundamental component E1 and E2, they are going to be added. I hope it is clear, beta. All of you, please tell me quickly, are you comfortable with this? Why the even harmonics are not present? Now we can say, beta, if you see, because of this analogy, if you want to write the odd harmonics are in the same phase, on the two sides of the coil, whereas even harmonics are in the opposite phase in the two coil side. Cancelling each other. Is it clear? So what are the harmonics you are going to have? You can easily list down what are the harmonics you are going to have. It is going to be fundamental component, 3rd, 5th, 7th, 9th, 11th, 13th, 15th, 17th and so on. Now you please try to understand, this is the fundamental, this 3, 3rd, 5th and 7th harmonic we call as the dominant harmonics. We call them as the dominant harmonics. And the remaining harmonics we call as higher order harmonics. Higher order harmonics. These are less dominant. What is the meaning of less dominant? Less dominant means you can ignore them, but if you come to the dominant harmonics, they are going to play an important role in the construction and the understanding of the machine. Now let us come to the armature winding classification, and I want to give you some important data. So please see here how we are going to understand this. Why we are using the distributed winding? Distributed winding beta we are using to remove the higher order harmonics. Higher order harmonics. If you come to the short pitch coil beta we are using to remove the dominant harmonics. And why we are using fractional slot winding beta? Fractional slot winding we are using to eliminate this beta. We are using fractional slot winding to eliminate the slot or tooth harmonics. I hope it is clear to all of you. Now we are not discussing Deva Santosh beta about the best book about the machine. There is no best book. The simple books, but you have to read them properly. I can tell you P.S. Bimra, Nagaraj Kotari, the basic books you have to read, but you have to read it with your whole heart. That is the only condition. You will get everything what is required for your examination if you simply read those standard books with all your concentration and confidence. I hope it is clear to all of you. Now about these different harmonics, if you want then I can take a class on that, but right now we are not going into the details of these harmonics. But if you want a separate class on harmonics in the synchronous machine, then I can plan it out in the coming future and we can have a separate class for this harmonics also. Now let us proceed. Is it clear to all of you? Please tell me quickly. Are you okay with this? Are you okay with this? Please tell me quickly. Now beta, we are going to discuss what is pole pitch. Okay. Now in the yesterday class we have beta discussed. In the yesterday class we have discussed what is a pole pitch. Let us again have a look on this pole pitch. Okay. I have given you one general idea. Suppose you are having a 4-pole machine. Suppose you are having a 4-pole machine. Just to give you example, don't get trapped in this salient pole and cylindrical pole debate. Just to make you understand this better. Anik Mitra is asking, sir, what is space and what is time harmonics? Better, that is what I was telling you, that if you want a detailed class on harmonics, then I can plan it out in the near future and you will be informed for that, because I have to tell you a lot of things. But in simple, to answer your doubt, better, space harmonics is because you can say because of the air gap. If you see your machine, synchronous machine, salient pole rotor, so the pole is chamfered, so air gap is not uniform. I hope it is clear. Even if you go for a cylindrical rotor, if you are going for a cylindrical rotor, suppose you are having a slot like this. Okay, for the rotor side I am saying, suppose you are having a cylindrical rotor. So this is what is happening. Here the air gap is more. Here the air gap is more. If this is the stator surface and if this is the rotor, and if you see here the air gap is less. So because of this unequal air gap, because of the slots or the tooths, you are having slot or tooth harmonics. Now this slot and tooth harmonics a part of space harmonic. So you can say space harmonic is related to the non-uniformity in terms of spatial distribution. But if you come to the time harmonics is when you are having the generated EMF, the generated EMF side harmonics, what you are having, that we are calling as time harmonic, you can say. Okay, so if you want to have a dedicated class on harmonics, I can take it, no problem. I will plan it in the near future. Let us go through the schedule, whatever schedule we are having, and at the end of that schedule, definitely we are going to plan a dedicated class for the harmonics, no problem in that. And suppose any day if we are having enough time, then I can go with that. Now suppose you are having this way, north pole, south pole, adjacent pole of pair. Now what is happening beta? If you go from this north pole to this south pole, this we are calling as the 180 degree electrical as the pole pitch. Why beta we are calling it a pole pitch? Because if you are standing on the rotor, let me tell you again, if you are standing on the rotor, then the moment one north to south pole is covered, one cycle of EMF is generated. So your work is going to be completed from a movement from north to south. But when you are standing on the ground, when your reference is ground or the stator, then if you see the actual angle here is going to be 90 degree, but this is in mechanical degree. But if you see here, it is in electrical degree. So if you are going to write the pole pitch in terms of electrical degree beta, it is always going to be 180 degree electrical. Now you tell me, if you are having a north pole here, so definitely you are going to have adjacent south pole, because you must be knowing that north pole or the south pole in terms of magnetic field, they cannot remain individual. They cannot remain standalone. So if you are having north pole, then you are having south pole. If you are having south pole, then you are having north pole. So the north and south pole are always going to appear in pair. So beta, you can always say that each pole is going to give you an angle of 180 degree electrical. Yes or no, you tell me. First, you should be 100% confirm with this statement that each pole is going to give you 180 degree electrical. Yes or no? The moment you go from one north to one south, it is going to be one pole pitch, 180 degree electrical. It means whenever north is there, south is there. Whenever south is there, north is there. So every pole, each pole is going to give you 180 degree electrical. Now if you are having a p pole machine beta, so how much electrical angle you are going to have? You are going to have p into 180 degree electrical. I hope it is clear. But the mechanical angle, total mechanical angle is going to be 360 degree. Yes or no? If you go in a circular fashion, what is the total mechanical angle? If you are standing on the ground, if your reference is stator. Yes, Subramaniam Suresh, you can say like that. In case of magnetic systems, monopoles do not exist. So if you see now the relation between this electrical angle and mechanical angle, what is the total electrical angle for a p-pole machine? It is going to be p into 180 degree. And for mechanical angle, it is going to be 360 degrees. So beta, you can say it is going to be p by 2. So you can say theta electrical is p by 2 theta mechanical. All of you, please tell me, are you comfortable with this? And if you have any doubt, then you can ask me. Now I think you will never forget this relation theta electrical is equal to p by 2 theta mechanical. I hope it is clear to all of you, beta. Yes or no? Now beta, we want to discuss the coil span. What is the coil span? Some of you may be comfortable, some of you may not be comfortable. Just focus here and you will understand this. Suppose this is a coil and these are the two coil sides. Suppose AB and CD like this. Okay. This portion beta we call as overhang portion. Okay. And if you see this portion beta, this portion, whether it is AB or DC portion, this beta we call as coil sides which have the conductor. What we are calling as conductor? Conductor is that part of the coil which actively takes part in the electromechanical energy conversion process. So beta, this coil, it can have n number of turns. This is a 1-ton coil. If you want to have a 2-ton coil, then you can have a 2-ton coil like this. You can have a 2-ton coil like this. If you want to have a 2-ton coil, then you can have a 2-ton coil like this. So beta, you can have a 2-ton coil like this. I hope it is clear. But again, this coil side is going to be AB. What is the meaning of this? A coil can have n number of turns, whether 1 turn, 2 turn or a multi-turn coil. But coil sides are always going to be 2. This is one coil side and this is second coil side. I hope it is clear to all of you. Now beta, this distance between the two coil sides AB and CD, this distance we are calling as the coil span. I hope it is clear to all of you. This beta we are calling as the coil span or the coil pitch, and this beta we are denoting with the angle beta. Is it clear to all of you? Yes, Raghuveer, you are right. Now we have already discussed that if you are having this coil span or the coil pitch, if this beta is less than 180 degree electrical, which is the pole pitch, then it is going to be a fractional pitch or short pitch coil. If the coil span is less than 180 degree electrical or the pole pitch, then we are calling it a fractional pitch or short pitch coil. शंकर नटराजन बेटा, अगर आपको नहीं मिल रहा है, if you are not getting those lectures, it is better you transfer yourself after this class to the Gradeup app and you will find it. And still if you don't find it, I will give you a contact number in the end of this class, or I will give you an email ID. You can go to that, you can see the link in the description and you can go there and you can ask your doubt and you will be provided with the link to see all the videos. I hope it is clear, beta Shankar. Now let us proceed with this slot pitch or slot angle. Okay. What is the meaning of this slot pitch or slot angle? You all of you please see here, it is very important. And if you understand this, then you will understand the remaining concepts very easily. You just focus here. Suppose beta you are having like this, and suppose these are the slots. Okay, so if you see this beta we are calling as this angle we are calling as the slot pitch or slot angle, and this beta we are denoting with gamma. I hope it is clear to all of you. So for each slot, because if there is a slot, so definitely there is going to be another slot. So in between two adjacent slots, the angle we are defining as the slot angle or the slot pitch. I hope it is clear to all of you. Now suppose, for example, you are having 12 slots. Yes or no? Suppose you are having 12 slots. What is the meaning of 12 slots? How many number of slots per phases you are having? If it is a 3-phase system, so it is going to be slots per phase. You are having 4 slots per phase. So how much spread you are going to have? You are going to have 4 into 180 degree electrical, because from one pole to another pole you are going 180 degree. So it is going to be 4 into 180 degree. So for one slot beta it is going to be how much? For one slot it is going to be 4 into 180 degree upon 12. What is this 12? Number of slots. And what is this? This is number of slots per phase. So you can define this slot angle gamma as 180 degree divided by number of slots per pole per phase. Is it clear to all of you? Please tell me quickly. All of you, please tell me quickly, are you getting this idea or not? Are you getting this idea or not? Please tell me quickly, are you getting this, how to derive this formula? If you don't understand this formula, then the remaining portion you are not going to understand. I am not asking to solve you, beta. I am not asking to solve you. You just tell me, if you are having a 12 slots, suppose there are total 12 slots, number of phases are 3. So there is going to be 4 slots per phase, yes or no? If I ask you phase spread, how much phase spread it is going to be? 4 slots per phase. Now for every pole beta, you are having 180 degree electrical. So it is going to be 4 into 180 degree. Yes or no? So for one slot it is going to be how much? For one slot it is going to be 4 into 180 degree divided by 12. And if you keep this 4 here, so it is going to be 180 degree divided by slots per pole per phase. Is it clear to all of you? And even if you are not getting it, then you can take it as number of north pole is equal to number of south pole. Yes or no? So if you talk about a single phase, in a 3-phase system, if you are talking about a single phase, so you just calculate number of slots per pole per phase and you divide it by 180 degree electrical, that is the pole pitch, from one pole to another pole. So one pole to another pole, you want to see how many slots per pole per phase, and you will get the one slot angle that we are calling as slot pitch or the slot angle. Is it clear, beta? I hope it is clear, beta. Now, beta, let us go, and if you want, I can give you a single statement. What is this slot angle or the slot pitch? Then, beta, we can write it as it represents the phase angle between the two adjacent slots. Simple definition you can have. I hope it is clear, beta. Now you see, let us see the short pitch winding we want to discuss. Short pitch winding. What is short pitch winding? You please focus here for some time and we will try to understand what is short pitch winding. Suppose this is you are having as the north pole. All of you, please ignore, if anybody is disturbing the class, please ignore them and you better focus on the class. Okay. Suppose, beta, you are having something like this. This is north pole and south pole, and suppose this is you are having the coil sides. Okay. So, beta, if you are having something like this, okay, suppose this is going to be AB coil side and this is going to be CD coil side. This is north pole, this is south pole. So what you are having? You are having a coil span. What is coil span? Beta, and this beta is equal to 180 degree electrical, because you started at this point and the similar point on the adjacent pole you are getting here. This point and this point are similar points on the adjacent pole. So if your coil span is equal to the pole pitch, that is 180 degree electrical, so it is going to be a full pitched coil. Full pitched coil. Yes or no, beta? Now Shankar Natarajan is asking, sir, it is actually slot angle. Now you listen to me, beta. Suppose there are number of slots on the periphery. There are number of slots on the periphery. Now all these slots are going to be divided among three phases. There are three phases now, beta. If you are going for a three-phase system, three-phase winding, so there is going to be A phase, B phase and C phase. So it is not just slot per pole, it is slot per pole per phase. That should give you 180-degree electrical. I hope you are getting this. I hope, beta, you are getting this. Now, beta, if you are having a short pitch coil, so what is happening? Please see here. If you are having a short pitch coil, so what is happening? Suppose you are having something like this. You are having something like this. Just focus here. You are having something like this. I am just writing it like this. If you are not happy with my diagram skills on this, then you don't worry. Understanding the concept is more important. Now, beta, what we are going to do, if you see this angle, we are calling as alpha, and this we are calling as the short pitch angle. It means instead of going to the 180-degree full electrical pole pitch, we are just reducing it a little bit. Now, why we are going to do this? You go to the first slide. Why we are going to do this? You don't forget this. This is very, very important. Why we were using the short pitch winding? We were using the short pitch winding to remove the dominant harmonics. Yes, Raghuveer beta, you are right. So it is going to be a dominant, to remove the dominant harmonics, we are going to have the short pitch coil. I hope it is clear to all of you. Now if I ask you, then this, and this is also called chording angle. This is also called chording angle. So beta, this alpha plus beta, it is going to be always 180-degree electrical. This is very, very important. I hope it is clear to all of you. Now beta, see what is happening. What is happening? If you are reducing the coil span from 180-degree electrical to, from 180-degree electrical to a little bit less, alpha electrical degrees less. So what is happening? If there was EMF E1 in this side, coil side, and here it was E2, when it was a full pitch coil, so both of them were in phase. Yes or no? Both of them were in phase. If you are having a full pitch coil, for the full pitch coil, what is happening? It is going to be something like this. Both this E1 and E2, this is E1 and this is E2, they were in phase. So they were simply adding. So it is the algebraic sum when it is the full pitched coil. But beta, when you are having a short pitch coil, what is happening? When you are having a short pitch coil, the situation is something like this. If this is your E1, then because of that short pitch angle alpha, what is happening? Because of this short pitch angle alpha, your E2 is going to be somewhere displaced. So what is going to happen? What is going to happen, beta? And this displacement, beta, we are calling as alpha. It is clear to all of you? Suppose this is E1 and this is E2, and let me tell you, the magnitude is going to be same. With some approximation, you can easily say that the magnitude of induced EMF is going to be same, even if it is a short pitch coil. But the only thing is, there is a displacement because of that short pitch angle. So what you have to do, if you want to know what is the pitch factor, coil span factor or the cording factor beta, what you have to do? You have to find this resultant, suppose this is ER, when there were short pitch coil, and divide it by the full pitch coil. So what is cording factor beta? How we are defining the cording factor? We are defining the cording factor Kp as the resultant EMF per coil for a short pitch coil divided by the resultant EMF per coil for a full pitch coil. Now if you apply some trigonometric information, you all must be very much aware with that, and you must have read this, that this distance AB is going to be how much? This distance AB beta is going to be 2E cos alpha by 2. Simple geometry explanation you can use. And if you go to this resultant EMF per coil in case of full pitch coil, so this is going to be 2E. So beta, your pitch factor is going to be cos alpha by 2. And all of you listen to me. It is going to be very important the way we are going to discuss it. Now if you are writing it for the nth harmonic, if you are writing for the nth harmonic EMF induced, if you want to see for the nth harmonic, so this factor is going to be how much? This is going to be cos n alpha by 2. Cos n alpha by 2. But you don't want harmonics in your output induced EMF, yes or no? You don't want harmonics, so what you are going to do? To eliminate nth harmonic, what we are going to do beta? This n alpha by 2, it must be 90 degree because cos 90 is 0. So you are getting the alpha as 180 degree divided by n, where n is the harmonic which you want to eliminate. I hope it is clear to all of you. I hope beta it is clear to all of you. Now just do this question and tell me the answer. If you have understood this coil span or the coil span factor or the pitch factor, tell me quickly what is the answer to this question. The coil span to eliminate 7th harmonic, how much coil span should be? In terms of pole pitch, you tell me. You tell me in terms of pole pitch. Quickly solve this problem. How we are going to do it beta? See, we know that for the nth, suppose it is the nth harmonic. So for the 7th harmonic, this is going to be Kp7. So it is going to be cos 7 alpha by 2. That is the coil span factor for the 7th harmonic, and this angle we are saying this should be 180 degree. Yes or no? Sorry, not 180 degree, 90 degree. This we are saying 90 degree. So beta, this alpha you are getting how much? You are getting 180 degree divided by 7. What is this 180 degree electrical? This is pole pitch. Okay, Anik Mitra is giving the exact answer. I am asking you beta in terms of pole pitch. So it is going to be, alpha is going to be 1/7 of the pole pitch. Okay. When I asked the question, I was asking coil span. First thing, I was asking coil span. Second, I was asking the coil span in terms of pole pitch. Why pole pitch? Because pole pitch is always 180 degree electrical. So it means your alpha, that is the chording angle, is going to be 1/7 of the pole pitch. So what is coil span? Coil span is beta. So beta is going to be 180 degree minus 180 degree upon 7, or you can say 180 degree 7 minus 1 upon 7, or you can say 6/7 pole pitch. And what is pole pitch? What is beta pole pitch? Pole pitch is beta going to be slots per pole. Pole pitch is beta defined as slots divided by number of poles. I hope it is clear to all of you. I hope you are getting this. Now from here we are going to understand very important point. What is that important point? If you want to remove the 7th harmonic, then you are having 7 minus 1 upon 7 of the pole pitch. This is the pole pitch. Suppose you want to remove the nth harmonic. So how much should be the coil span in terms of pole pitch? It must be n minus 1 upon n pole pitch. Is it clear to all of you? Please tell me quickly. Even if you are finding the exact value, there is no problem. I just wanted to understand this concept that if you want to remove the nth harmonic, then what is the coil span? The coil span should be n minus 1 upon n pole pitch. This formula can be directly asked in your examination, so beta it is important. Now just do this problem. The short pitch angle to eliminate the 5th harmonic. See, Deva Santosh beta, see, whenever you are talking to someone, not even your teachers, whenever you are talking to someone to whom you don't know, it is my humble request because I teach ethics. So let me tell you, all the candidates I am telling you, if you are having a conversation with someone whom you don't know, it is important that you should be humble enough and you should put your question or the statement or the conversation in the properly right manner. I hope it is clear to all of you. All these queries, beta, you can talk to the concerned person on the Gradeup app and he is going to answer you. I hope it is clear. Now again Anik is giving answer in terms of actual values. It's okay beta, no problem, but I want this short pitch angle, that is alpha, in terms of pole pitch. I want it in terms of pole pitch. With reference to pole pitch, it is going to be how much? For the 5th harmonic, it is going to be Kp5, it is going to be cos 5 alpha by 2. And this 5 alpha by 2 must be 90 degrees. So you can say alpha is going to be 180 degree upon 5. But this 180 degree electrical is what? This is pole pitch. So it means alpha for nth harmonic, it is going to be 1 upon nth of the pole pitch. I hope it is clear to all of you and you will remember these two formulas. To remove the nth harmonic, what is the chording angle alpha? It is going to be 1 upon n pole pitch. And what is the coil span beta? It is going to be n minus 1 upon n pole pitch. It is okay? Yes, Anik Mitra, you are right. Now just try to solve this problem. Now please try to solve this problem, because if it is directly given, direct value is asked, then I know that you people can easily sort it out. But if it is given in terms of pole pitch, then it is going to be little difficult to answer it when it comes in the GATE examination or the engineering services examination. So it is better you remember these two formulas, it is going to be very helpful for you. Now beta, He is saying the coil span of an alternator is 2/3 of the pole pitch. What is coil span? Beta. It is going to be 2/3 of the pole pitch. Now he is asking which of the following harmonics is eliminated. How you can write this beta? This beta you can write beta as 3 minus 1 upon 3. So directly you can say which harmonic it is going to eliminate. Third harmonic. Yes or no? Directly you can identify it. Without solving, if you just remember the formula, you can find it out. I hope it is clear to all of you. Now beta, we are going to take the next one, but before that there is important information for all of you. Now just focus here. For the target gate course, the important highlights are you are going to get 550 hours of live classes, 5000 plus practice questions, study notes, full length mock test, daily test and subject wise test. It's okay beta, all of you. And these are the important dates. These are the beta important dates for this target gate 2021 course, and most important date is 11th May because it is the date when GST is going to be conducted. You can take the snapshot. If you have any query, all the candidates, then you can contact this number or you can write to this email ID. I hope it is clear to all of you beta. Now beta, we are going to discuss the distributed winding. Okay. Beta, question, just quickly note down the question. Deva Santosh beta, if you have any problem, whether it is internet problem or any other problem, then you can directly contact the concerned person on the Gradeup team. I am sure that he is going to help you, and if you don't get the required help, then in the next class you please tell me. I will personally take interest in your problem and I will try to sort it out if there is a possibility. Students, one of the great faculty of civil engineering, that is Abhinav Negi sir, is in between us. Please welcome him by saying hi in the comment section. Hello Abhinav Negi sir, how are you? All the candidates quickly say hi to Abhinav Negi sir. He is one of the great faculty of civil engineering. Okay friends, now let us go to this distributed winding. I hope it is clear to all of you. Now beta, please see here what is happening. What do we mean by this distributed winding? What is the overall idea? Please try to understand. What is the idea of having this distributed winding? Okay, what is the idea of having this distributed winding? Please see here, very important thing. Suppose you are having two poles like this. Okay, just bear with my artistic innovation. Suppose this is your north pole and this is your south pole. Now suppose how you are going to have the windings. Just see carefully. How you are going to draw the windings if you are having a distributed winding. Please see here. Okay. Suppose it is something like this. I am making it in front of you so that beta you understand this. This is very important, don't take it lightly. I am making it, I could have taken a diagram also, but then beta you will not understand how we are constructing these windings. Please try to focus on the diagram. It will not be required in your examination. It will not be required in your examination, but definitely it can be asked in the other way. Just have a little patience and you will understand the point. Suppose it is something like this. Now see what is happening actually, and then you will actually understand what is this distributed winding. Now this beta we are defining for the R phase. The windings we have shown them for the R phase. Suppose there are three phases. What is the phase sequence? R by B. So first I am drawing it for the R phase. Suppose this is R1, this is R2 and this is R3. Okay. Similarly there are going to be the other windings. Suppose next windings I am going to draw with a black color. We are not going to draw the full windings, but to make you understand how these windings we are saying as distributed windings. Okay. So beta these three we are calling as the R phase. Okay. These three beta we are calling as B1 dash, B2 dash and B3 dash, and this beta we are calling as Y phase. So this is going to be Y1, Y2 and Y3, and these are the written side of the B phase coils. I hope it is clear to all of you. Now what I am trying to make you understand, sir. Beta EMF polygon is very easy and everybody knows about that EMF polygon. That I will definitely discuss, don't worry about it. But first beta we want to understand the phase group or the phase belt or the phase band. That is more important. That polygon is very easy, you can find it out, no problem. But I will discuss that also, don't worry about that. Now beta this section which is dealing with this R phase, this beta we are discussing as the phase belt or the phase group or the phase band. Deva Santosh, I can understand your emotions because this is not daytime, this is night time, and I can understand that if somebody is teaching you these windings in this time, then your anger is very logical to me. But it is for those people who are interested, who want to understand this, who want to read this, for them it is important. I hope it is clear to all of you. See, that EMF polygon is very easy, that we will discuss, no problem with that. But beta, we want to discuss this phase group, phase belt. That is very important, because if you don't understand this, so what you are seeing, this total pole area we are defining under three phase belts or phase groups. That is the idea I want to convey to you. Now you see here how we are defining this phase spread or phase group or phase band. It is the angle subtended by the phase belt. Yes or no? I hope it is clear to all of you. No, Ranjit Mahal beta, they are not in the same slots, they are in different slots. They are in different slots. I have not made the slots, I have only told you about the phase spread. If you want, then you can draw the slots also. It is not in the same slot, this is the pole. You can draw it like this. If you want to see the slots also beta, then you can see them like this. So this way you can draw the slots also. You just focus here. What I wanted to convey, that is important. I was saying it is the angle subtended by the phase belt. Now you take one example. I am giving you, take one example. I am giving you one example. Suppose it is a 3-phase, 2-pole, 18-slot alternator. You take this example. What is going to be slots per pole? Slots per pole beta is going to be 18 by 2, that is 9. What is going to be slots per pole per phase? It is going to be 9 divided by 3, that is going to be 3. Yes or no? Now what is slot angle or the slot pitch that we are defining as gamma? Beta, it is going to be 180 degree divided by slot per pole. What is slot per pole? 9. So it is going to be 180 degree divided by 9. So beta, it is going to be 20 degree. I hope it is clear to all of you. Now beta, if you see, for this configuration that I have shown you, all this R phase, we are using how many slots? We are using 3 slots. Just take the example. Suppose you are using the 3 slots to have this R phase. So what is the total angle subtended by this phase belt or phase group? I am saying that the slot angle gamma is 20 degrees. So what is the phase spread you are going to write? The phase spread is beta going to be, 3, because I have used 3 slots. So multiply by 20, so it is going to be how much? It is going to be 60 degree. This is how we are going to calculate it. It is clear? Now you can write it in this fashion also, 180 degree divided by 3. Yes, Ranjit Mahal, you are right, per phase. So if you want to know the phase spread for a n phase system or the machine, then it is going to be how much? It is going to be 180 degree divided by 9. Now suppose you want to see it for the single phase. For the single phase, what is going to be phase spread? That is going to be 180 degree. If you want to see it for a 2-phase machine, so it is going to be how much? It is going to be 180 degree divided by 2, that is going to be 90. If it is going to be a 3-phase machine, so this is going to be 60 degree. Now you remember this point, this is phase spread. Now you tell me, what do you mean by this phase spread? You please tell me. If I tell you, suppose beta, I tell you, this M is the number of slots per pole per phase. This I am telling you, number of slots per pole per phase, and I am telling you the slot angle gamma. This is the slot angle. You tell me what is the phase spread. What is going to be phase spread? Nothing but M multiplied by gamma. This is going to be phase spread. Yes or no? Is it clear to all of you? Please tell me quickly. Is it clear to all of you? Please tell me quickly. Now beta, suppose I want to discuss that EMF polygon that one of the student was saying, to describe the distribution factor, to explain that distribution factor. So how it is going to be, just see here beta. Okay, Suppose the EMF induced beta you are having in this fashion. For each slot you are writing suppose like this. Okay. I am just trying to make it simple for you. Please try to understand. Now beta, this angle we are saying, this angle we are saying as gamma. What is gamma? Gamma is the slot angle. So for each slot you are having like this. So can you tell me what is this total angle? This total angle is beta going to be how much? This is going to be the phase spread, that is m gamma. Yes or no? Now I want to know the phasor sum. I want to know the phasor sum of all the coils of phase A. Suppose we are talking about phase A. So this is going to be E1, this is going to be E2, this is going to be E3, this is going to be E4, this is going to be E5, this is going to be E6. For all the slots, the distributed winding, what is the resultant beta? The resultant to all these is going to be how much? This is going to be this ER resultant. Yes or no? So, if I ask you to calculate this distance, can you tell me? Directly you can tell me yes or no. If you are having this triangle OAB, what is going to be AB? Please tell me. You draw a perpendicular from this O to AB, yes or no? Draw a perpendicular from this O to AB. Suppose this situation is something like this. This situation is something like this. This is beta O, this is A, this is B. This total angle is beta how much? M gamma. Now I am asking you to draw a perpendicular from this O to AB. Yes or no? Suppose this is C. And if you have to calculate AB, what is going to be AB? AB is going to be 2 times AC. Now you see in this triangle OAC. What is this angle? This is going to be half because it is a perpendicular bisector. So this angle is going to be M gamma by 2. Yes or no? Now you apply this. This is R. Suppose this is R. So this is going to be R cos M gamma by 2. And what is this distance? Beta, this distance is going to be R sin M gamma by 2. So AC is going to be R sin M gamma by 2. So the total AB is going to be 2 times R sin M gamma by 2. Now suppose if it is a concentrated winding. If it is a beta concentrated winding, so it is going to be how much? Yes. Anik Mitra beta, see here. If it is a concentrated one, so there is going to be no phase difference, phase displacement. So all the EMFs are going to be algebraically added like this. Yes or no? I hope you are getting this. And it is going to be how much? You tell me. Number of slots per pole per phase. Slots per pole per phase. N. So it is going to be beta how much? It is going to be M, and this multiplied by 2R sin gamma by 2. I hope it is clear to all of you. And if you want to define the distribution factor or the breadth factor, then you are going to write it like this. Suppose it is going to be the vector sum for a distributed winding and it is going to be algebraic sum. So it is going to be how much beta? This is going to be 2r sine m gamma by 2 divided by m 2r sine 2 sine gamma by 2. Yes or no? Now this 2r is going to be cancelled and you are going to get the formula for this distribution factor as sine m gamma by 2 divided by m sine gamma by 2. Prashant is asking, sir, distributed winding and three-phase lap winding both are same or different? Now you have asked a very fundamental question, but beta, you listen to me. You listen to me very properly. You can say that distributed winding is something similar to the lap winding. I am saying it again. You please try to understand. I am saying that distributed winding is something similar to the lap winding, but it is not lap winding. Because lap winding and wave winding, they are closed windings. Whatever we are discussing here is beta, it is going to be open windings. When we will discuss DC machines, I think there is one lecture also, it is available in the Gradeup GATE channel about the armature winding in DC machine. There I have explained this closed winding and open windings. I hope it is clear. Anik Mitra, please tell me, are you getting this EMF polygon or not? How to calculate this distribution factor? See, we have to discuss lot of things about this distribution factor, phase groups, 60-degree phase spread and 120-degree phase spread. All these things we have to discuss, but that we are going to discuss tomorrow because we are limited by the time beta. So this is the equation you are having for this distribution factor. I hope you all must be aware with that. No problem with that. Now beta, if you are having the nth harmonic, then again beta, you can write the distribution factor as sine mn gamma by 2 divided by m sine n gamma by 2. This is the formula we are having. And why beta we are having this? Why we are having this distribution factor for the nth harmonic? Because if you want to remove the nth harmonic, then you are using the distribution winding, and distributed winding you are using for higher order harmonics. You want to remove the higher order harmonics. You remember my first slide for the today's session. I hope it is clear for all of you. Now let us proceed and we are going to conclude this class because we are running short of time. And the next class beta, we are going to discuss, we were supposed to cover the characteristic parts also. So I try to cover it in the next class, don't worry about that. Now the important information regarding you is that in the next class beta, we are going to, after covering the remaining part of the today's session, we are going to take up the power angle characteristics of the cylindrical rotor machine. So all of you please be there in the next class. It is going to be very interesting, very knowledge class for you. So don't miss this class, and let me tell you, please try to share this video among your friends and colleagues because we want more number of people to join us in the live session. Then only we will be able to continue with these sessions, because we are putting lot of efforts even in this difficult situation. 24/7 our backend team is working to provide all these lectures to you, but it is very important that there should be a positive response from your side also. So beta, let me list out what are the topics we are going to cover in the next class. First thing, we will see the remaining part of the phase group, 60-degree phase group and 120-degree phase group. Then we will see the remaining part of the armature winding, that is the integral slot winding, fractional slot winding. All these details we are going to see. Then we are going to see the characteristics of the synchronous machine, and then we will see the power angle characteristics of the cylindrical rotor machine. Is it clear, beta? All of you, please tell me quickly. Are you comfortable with this? And if you have any doubt, then you can ask me. Otherwise, quickly I am going to conclude this class. All of you, please quickly tell me. And let me tell you, beta, that there are 60 plus Gradeup students in the top 100 in the GATE 2020 examination. And if you want to be in this list, you have to do, beta, two things. Shankar Natarajan is very adamant about the link to those 16 previous lectures you told you will send at the end of the class. I was not saying, beta, that I will send you at the end of the class. I told you that I will give you the link. In the description it is mentioned, so you just try to contact to the concerned person on the Gradeup app, and if it is not being provided, then I will help you. But I am sure, beta, that they are going to provide you the link. You just contact to them, beta. Now let me tell you, beta, if you want yourself to be in this group, top 100 people, then you have to do, beta, two things. Number one is hard work, and what is number two? Number two is again hard work. That is very, very important, all of you. So friends, don't forget to join me at 8:30 p.m. in the night to read these electrical machines for your GATE and engineering services examination. We at Gradeup want to enhance your learning and interest in your subject like electrical machines and other subjects. And if you have any query regarding the way we can improve our lectures, I can improve upon my lectures, then don't forget to tell us your suggestion, tell your comment, so that we can improve upon our lectures, so that it is beneficial for you and the rest of the students. Thank you so much, friends. I wish you all the best for your upcoming exams. We are going to meet again 8:30 p.m. Monday to Saturday to learn electrical machines together. Thank you so much for your time. Prep smart, score better, go Gradeup. Thank you so much.